What I like about being in this line of business and distribution is that I get to be involved in a lot of the behind the scenes work that goes into much of what runs the infrastructure of our world. Distribution and the companies we work with help supply the boring stuff that makes the cool, pretty stuff run. In this case, we're all aware of the blinking, high power, cool computer processors that power and crunch the data for the fun, functional, powerful stuff on our phones, our desktops, running BIM, and even the con-tech equipment on the job site. Those blinking light processors and servers, well, they're just part of the story. With AI computing increasing daily, we're seeing a heating and power consumption problem. Engineers continue to improve the design of the processors to be more efficient. At the same time, there are hundreds of companies creating products that bring power, cooling, data pipelines, connections, et cetera, to those servers. They are working to make sure those servers run cooler and more effectively. Today, I'm going to be speaking with someone from one of those companies supporting that infrastructure, and that's Panduit. Bob Wagner is Panduit's Senior Development Manager for Data Centers, and he and I will be breaking down the heating and power consumption dilemma. We'll also discuss the ways the infrastructure can dissipate the heat and support the work of the processors. Before we get into the show, let's get to know our guest. I asked him, who is Bob Wagner?
A kid from a medium-sized town in the Midwest and was very good at math, so he went into engineering. Found out in his first engineering job he was too energetic to sit at a table very long, so decided to go back to grad school and get into business, and has been doing that ever since. And is lucky enough to be one of those people that fell into exactly what he wanted to do: create new products, develop new things, and stay close to technology.
Welcome to Keeping the Lights On. I'm your host, Todd Reed, and on this podcast, I connect with the owners and pros who design, build, and maintain our electrical, communications, and industrial world to explore the best ways forward. Before we get going, let's hear a word from our sponsor. AI is transforming industries, and it all starts with the infrastructure behind it. Whether you're expanding your data center or upgrading for next-gen performance, Panduit has you covered. Now, Panduit's trusted solutions, from high-density fiber to intelligent power distribution, are engineered to handle the speed and scale AI demands. And working with their distribution network, you'll get what you need, where and when you need it. See the links in the show notes to visit graybar.com to explore Panduit's AI-ready infrastructure solutions today. Okay, let's get into the show. Well, Bob, as we talked about before, like to start out each episode with the meals that bring us together. So, Bob, if I or one of the listeners, viewers, were to visit you in your hometown, where might you take us, and why would you choose this place?
Oh, that's an easy one because I live in Naperville, Illinois,
Mm.
and we have a lot of good restaurants, but Maison Sabika, it's a tapas restaurant
Mm.
that is cannot miss it during the summer. They've got this huge patio, big oak trees overhanging. The food's great, the sangria is great. It's just we have such short summers in the Chicago area that to get outside, everybody wants to do it, and that is the best spot nearby. It's really good food.
Awesome. Well, you mentioned a drink, but do you have a favorite food item that you love to get there?
Well, there's a couple of them. The Pincho de Solomillo is basically skewers of beef with horseradish and some onions. And then the other really good one is dates wrapped with bacon. Obviously, putting bacon on anything is good, but theirs are fantastic.
Oh, that sounds great. The only problem about asking these questions at 10 a.m. is that I'm like, oh, great, now I'm hungry. I'm going to cut this short. Naperville's not too far from here, relatively speaking. All
Are you
right.
in
Well,
St. Louis?
yeah, I'm in St. Louis, so
Okay.
yeah, I can get there. You know, dinner time. Hey, so that restaurant, very likely there is some process in that restaurant that they're utilizing AI. I mean, who isn't using it somehow? And we're probably using it when we don't even know we're using it, frankly. And so AI computing, I mentioned in the intro, and it certainly it goes unsaid. It's the computer use for that is growing in the power usage, but there's a lot of challenges with the heat generation, and power consumption because of AI computing. So, what are some of those new challenges that are popping up day by day as AI computing power continues to grow?
Yeah, you're seeing the power consumption needs shooting off the charts. Um, we were just looking at this back in 2014. The Uptime Institute did a survey, and that survey thought we'd be at 40 kilowatts per rack, which is actually where AI has got us now. But the odd thing is, when you look at a traditional data center, they're less than 10 kilowatts. So
Hmm.
jumping from 10 to 40, and now the newest NVIDIA system is over 100. It's about the NVL72 systems are 120 to 140 kilowatts. That's a gigantic increase. And then the roadmap that our friends at NVIDIA have developed in just a couple of years, they're going to be at 600 kilowatts per rack, not building, but rack.
That's
And
crazy.
so 10 to 600, that's a 60x increase. So what I'm always telling people is if you have a data center, it may be obsolete. I mean, because they just don't have the power coming into the building. They don't have the infrastructure inside the building to run power like that to one rack. They don't have the cooling. It's putting a ton of stress on data centers that were built just even a couple of years ago. So it's a big issue. And then, of course, from there it moves into the cooling. Okay, so now maybe I've got the power, and a lot of these buildings are 208 volts inside.
Mm.
That really isn't going to cut it, right? You just don't have enough. You have to be moving into 415 volts. So even if you get the power, now you've got to talk about cooling. And when you get to be 50 kilowatts or more, you can't blow air. It just doesn't do it. It's not strong
Mm.
enough. So now you got to look at liquid cooling, and there's several different styles of liquid cooling to look at. And every one of those comes with complications. In fact, I heard a guy from Digital Realty kind of joking, but not joking. I'm going to have to hire a lot of plumbers because it's either
Mm.
water or some other liquid, and it's going to be very prevalent in AI systems going forward.
How does all that demand for higher computing performance affect the space use in data centers?
There's a lot of questions about that because some people maybe a little lightheartedly would say, "Oh, I'm going to have this great data center, and I have 6 racks, and there'll be a bunch of empty space." Because those racks are operating, 120 to 600 kilowatts each. I just don't have enough power coming in.
Mm.
Um, but no, I don't really think that's going to be that way. When we talk to the biggest of the big, the hyperscalers, Microsoft, Amazon, Google's, et cetera, they're still driving density. They want smaller and smaller
Mm.
fiber connectors. They want to maximize that density. But I will tell you, I've also seen the other way is people using bigger cabinets and not worried about using bigger cabinets, which take up more space because there's more fiber than ever in these data centers, and they don't want to have this congested area where they just can't get the fiber to run, and they want to spread things out a bit. And when you're talking about air cooling and blowing air, which you still will do, even if you're using liquid cooling, you're still going to be blowing some air. Moving the rows farther apart is certainly a help as well. So
Mm.
I don't know. It hasn't really washed out yet. I mean, they still want the density in the rack, and they want things as close as possible, like server to server, GPU to GPU as close as possible. But they also, I think they're going to run out of energy and power coming into the building. And for thermal properties, they'll probably be spreading things apart. Rows will be farther apart.
Mm. So, can you walk us a little bit through how the cabling and pathways, which are affected by this shift to racks designed for AI computing?
Yeah, the first thing it is to think about is that most traditional servers use two fiber, which is a duplex LC. So they only have two fibers coming in. Now with GPUs, they're all going to use 8 fibers or potentially more in the future coming in. So they're using parallel processing, and that's an MPO. So that alone has quadrupled the amount of fiber coming into the server racks. And then the architectures, which is rail optimized, which is it's a it's a cloth. It's a different variation of spine leaf, which a lot of people are familiar with, but it's very intensive. And what they're trying to do is have every GPU talk to every other GPU, matter how big that cluster is, in the least amount of switch stops. Every time you go through a switch, you get latency, and they want
Mm.
lowest latency, and that just means they're talking is like one seamless brain. So if you can shrink all that and make them talk as one seamless brain, low latency, now you've really got a good AI computer. But to do that, it becomes kind of tricky. You basically have to start shoving and sending and routing fibers in many, many different directions. So there's estimates that the fiber usage is going to be 8 times more than a traditional data center. So if you're trying to retrofit an existing data center, likely you may have to pull out all your pathways that are above the racks because you just won't have enough space in there. This fiber takes up a lot of room. We're working with customers right now to take a bunch of individual fiber assemblies and shrink them into one single jacketed trunk because that dramatically reduces the space. Because even in the rack, especially when you're talking about like an NVL 72 system, all the fiber and even the copper for the out of band really gets into a congestion point at the top of those racks. And by shrinking those things down, by consolidating multiple cables into one jacketed cable, you can really help yourself and make it way more manageable.
So, what are the operational risks if heat and space challenges aren't addressed?
You don't have an option, to be honest.
Okay.
You really need to plan ahead. In fact, one of the main things when we talk to customers or we do any training to people, you gotta plan ahead. It's not like just another data rate increase going from 100 gig to 400 gig. That extra power, you really have to have a data center that can handle it. And if you're really going to start putting in some of these higher end systems, like a B200, B300, or an NVL 72, it becomes mandatory to have liquid cooling. And you just don't suddenly have liquid cooling. You have to have plumbing. You have to have a strategy. You really have to plan this out. So many people are saying, I want in AI. I got to get in AI. I'm going to buy myself some GPUs. And it's funny, I hear this every day. And then they don't know really what to do with them. They don't even know what their application will end up being. And they're having a hard time figuring out, how do I put all this together? You got to plan ahead. You got to think about the power first, and that'll lead you into the thermal and the cooling. And then you've really got to lay out enough pathways and permanent infrastructure to handle everything you're going to put in.
So, are there challenges unique to retrofitting existing data centers compared to building new ones for AI?
Absolutely. A lot of people are saying, ooh, I'm just going to go build a new one. And that's why we're seeing this giant boom. I mean, I was just reading the other day, I think it was from JLL and CBRE, that, they're the experts in this, saying that data center open capacity is like an all-time low. I think it's like they said 2 to 4%, which means, and I loved the one of their quotes was something about, build it and they will come. And we've all been joking about don't do that because, you really have to do more homework. They're talking about order ahead before they even build it. I mean, before these buildings are even going up, they've already signed someone to be inside of it.
Oh, wow.
So
Okay.
people have taken the pre-leasing years in advance just because they know their existing buildings are maybe not going to work very well with AI. But let's fall back. There's a ton of buildings out there that are very functional today. And as we move into more and more AI, they are going to have to be retrofitted. The first thing, as always, is power. What do you have coming into that building? Can you run 415 volts inside the building? Because if you can't, it's going to limit you, right? There's just nothing you can do. And getting a new power line from the grid, from your utility, get in line, that's going to be years in advance. So that's not going to be a quick runner. So that's your first thing to think about. And then from there, if you can get 415, or even if you're going to run a smaller AI system and run a 208 volts inside, then you can do that, but it's going to limit your scope. But those are the main things that you have to look at. And then, do you have a raised floor? Because you have a raised floor, not many people do in North America, but it's very popular in Europe.
Mm-hmm.
Then you can put all your liquid cooling underneath that raised floor because generally you have a lot of room. You were blowing air, now you'll just pump liquids. That's fantastic. But if you don't have it, and most North American don't, now it's got to be above. So now you need the plumbing put in place. And those connection points are very expensive because they're dripless. because you don't want
Mm,
water falling on your
no.
electronics because it's going to short it out and burn it out. And at, $200,000 a server, you really can't afford that.
Well, power is what we talk about a lot here because that's what your company, our company, the people we supply, that's what we deal with most of the time. But what's interesting to me, of course, and there's power challenges even with just charging for cars. And then now you got data centers coming in who have, they're hungry too for power. So that's another challenge. But what's interesting is the whole liquid challenge and water. And I'm not sure where we stand on as far as like water demands in areas where those, centers are being put in, and if that's pushing those infrastructure as well, the water usage and all that, because I know some of it's a chemical liquid, but I think there's some water usage from local infrastructure and utilities, I believe. So
Yeah, good question. So I have several friends in Phoenix, but you wonder
mm,
how long can they actually sustain all that? But you don't have to always use water. I'm just reading an article just the other day where a glycol or basically, coolant systems, they come with their own problems because you just don't like open up a drain and pour that down in because they're not
well,
good
right.
for the environment, right? That would be against the law. So you have to manage that, but you can get away with water by doing that. And I think you're going to be forced to. I mean, I sit in Chicago next to the world's greatest supply of fresh water in Lake Michigan, et cetera. But it's a scarce resource, and
Mm.
I think electricity is also starting to become a scarce resource. The utility companies can't keep up. You are seeing all of the big data centers that they're putting in place. What's a good thing is they're going with a lot of renewables like wind, solar, but they're having to be very, very creative. You're seeing people take leases on existing nuclear power plants, like Microsoft took a lease for I forget how many years on 3 Mile Island. Nuclear is back in vogue. In fact, there's these things called SMR, small modular nuclear reactors, which are maybe the size of a house, and those things are going to go right next door to these data centers, and you're going to see the data center guys become de facto utility companies. They're going to have to supply their own power because utility companies are just not going to be able to get the right of way to run new power lines to all these buildings. And the other thing is you can go, I hear a lot about hydrogen fuel a little bit farther out there, but it's going to be anything and everything is on the table for how do I generate the power. And then location. These big training systems that are scraping the entire internet to create your ChatGPT, large language model type systems, they're not going to be sitting next to a big building because excuse me, the big cities, because those cities don't have the power to give. They're
Hmm.
going to be out somewhere where power is plentiful, inexpensive, and so it's going to be, and you don't need to have the training systems generate and have low latency right to the customer. That's where the
Oh,
inferencing data centers are. So you
interesting.
can have a training system in the middle of Wyoming, not near any major population area, because they've got cheap land, cheap and plentiful power, and places like that are going to become very popular.
This is why I had you on, Bob. I didn't think about the scraping and the learning systems. That's pretty cool.
Yeah, there's a difference because there's a training data center
Training. Yeah.
and inference, and so the training
Hmm.
it's going to run and really use up a ton of power. It's got way more electronic servers, etc. But it's not on demand. It's training, and then it gives it to the inferencing data center using kind of the same equipment, but just a smaller system. Which then, when you and I hit a search, that's what we're talking to is that inferencing data
Mm,
center. Now that one's
interesting.
got a difference because it's going to be running 100% of the time,
Yeah.
constantly being hit. Where the training is going to do some massive, complex calculations and scraping, and then it may go dormant for a little bit.
Hey, want to interrupt the show real quick and ask you, do you want to keep up with the power demands and performance of AI? Well, start with your infrastructure. Panduit's scalable, efficient solutions are engineered to support today's most powerful data center environments. Think smarter cable management, faster connectivity, and modular designs that grow with your data center. All available through Graybar. Now, Panduit is powering the future of AI. Click on the links in the show notes to visit graybar.com today and see how your data center can keep up with tomorrow. Let's get back into the show. All right, well, we've talked about a lot of the challenges being faced, lots of heat, lots of power. So let's start to talk a little bit about some solutions, some ideas about what's working and where people are going to solve this heating, cooling, power challenges that are ahead of us. So let's start with how can a data center optimize power distribution to support these higher density racks?
Sure. So today's server cabinets will normally have two PDUs. That's just a power distribution unit. If you're not familiar with that, it has a lot of outlets. The servers will all plug into that. The servers have upwards of 6 power supplies each. And so you're always shooting for redundancy. So you have a PDU on the left side of the rack and a PDU on the right side, and you'll have half of the power supplies connected to the left, half to the right, meaning if you ever lose power on one side or something gets cut on one side, the other side will pick it up and the server won't go down, which is obviously hugely important. So that normal traditional takes two PDUs, one left, one right. When you start adding the power consumption needed by these high-end GPU servers, now you're starting to run out of power. And so now you start to say, oh, I need 4. And in some cases, when you do the math, I need 6 PDUs per rack. So that's 3 per side. And some of these are even so complicated that the server cannot be redundantly kept up. So if you lose the left side, the whole thing goes down. So you really need to do your homework ahead of time. It is not advantageous to try to put 6 PDUs in a rack. It takes up a ton of room. And then if you didn't know, a lot of these AI servers are much deeper, and the racks themselves haven't really gotten that much deeper. So your room in the back where these PDUs go, and where now if you're going to use liquid cooling, the liquid cooling goes, it's getting tight back there. And we're talking about congestion. I've seen a lot of the folks, the servers, moving their connectivity, all the fiber connectivity to the front. Dell was one of the first people to do that. I think that's really, really intelligent. Get that, cabling that can be damaged away from where the liquid cooling is, away from these power cords are. Very smart. But getting back to the power, you want to have, hopefully you can only get away with 4 PDUs. And then you need to talk about, what are my needs? How much intelligence do I have? You can go from a basic PDU that doesn't do much to one that monitors the power at an outlet level and can do a lot of management. You can even synchronize these together with sensors. Like a lot of people have locks, and you have to badge your into the cabinet to even be able to open it up, because a lot of expensive equipment, people don't want just anybody in there. You can actually cycle that through the PDUs back to the control system. So they're not just power units, they're actually information connecting systems that works with your control system back at the network office. So you have a lot of different abilities to make and add intelligence to your entire system using these PDUs. Now, when you get into these NVL72s, which are over 100 kilowatts per rack, NVIDIA and several other guys have decided, hey, we just can't have that many PDUs back there. Let's switch it all out and use a power shelf and a bus bar. So the OCP, which is Open Compute, which has been developed by Meta many years ago, it's an open forum, has come up with a bus bar. And that's just basically a big copper rail where all of the servers will plug into, and you're at 48 volts DC directly into the server. The nice thing about that, you're not going from AC to DC, you're just going DC directly in, and that it makes it more efficient. And being able to just slide things in is also a kind of a nice way to go. It does complicate things a little bit, but it's probably the way of future for things that are going to be over 100 kilowatts. And those power shelves I mentioned kind of take this place of the PDU by adding the intelligence, but But for the most part, they're really just taking it and making it DC. They're really just converting AC DC, that sort of thing. So that's where you're looking for the future.
So let's start out with the cooling technologies that are emerging as best practices for managing the heat generated by AI workloads.
Yeah, you have your options, and it all depends on where you're at as far as the kilowatts you're going to use per rack. And there's some obviously debate, so take what I'm going to say for just as a rough estimate.
Okay.
So around 50 kilowatts, give or take, is when you really run out of being able to use air containment and blowing air without any other additional factor to it. So at 50 kilowatts per rack, a lot of times you're going to want to move into a rear door heat exchanger. And basically think of that as the refrigerator you have in your house. It's basically pulling in water, it's cooling it off, and then blowing air through that. The rear door heat exchanger, you can take off and take, or excuse me, you can take an existing cabinet, take off the rear door, and then apply this rear door heat exchanger onto it. And it's in the same footprint. It's obviously thicker than a typical door, but you should easily have room. And now you've got a refrigeration unit. So as this hot air comes out of the servers and switches, it goes through the rear door heat exchanger and it's cooled so that going back out, your ambient air is going to be a lot lower temperature. And so it definitely keeps that the overall system cooler. So you can get those to run maybe up to about 70 kilowatts per rack. And that's about 75 is when you really need to start talking about true liquid cooling.
Mm.
The rear door heat exchanger has water going into it, much like your refrigerator does. But true liquid cooling, you got a couple different options. The one that's I think everybody's sure is going to be the most prevalent is direct to chip liquid cooling. Your chips, your GPUs, your CPUs, they all have these big heat sinks, which are just nothing but fins that are very thin, and you blow air over it. And much like an elephant has ears, and that's how they regulate their own temperature, because it's thin and has a lot of surface area. That's how a heat sink works. Well, you can take those monstrously big heat sinks out, and now you just replace it by maybe an inch at most cold plate. And the cold plate has cold water coming in, it circulates around. There's a lot of different technologies, but basically it absorbs all that heat coming out of the GPU or CPU. The water heats up and then it shoves it back out and it dissipates out and then it's cooled off in a tank outside the building. That's way more efficient because why? Instead of just blowing air everywhere, it's blowing or it's cooling the chip itself. It's
Mm.
right there on top of it. And that's very, very effective. And I think that's going to be very popular. The one that is even more efficient, and I should say that pumps with liquid use up way less energy than fans pushing air.
Mm.
But the one that is the most efficient is the immersion cooling. And that's where you literally take your server and you drop it into a tank of fluid.
Oh,
Now,
wow.
it's not, it's water, it's a dielectric fluid. And that works, the whole system is going to be cooled. It's expensive, it's complex, it really changes your architecture. So a lot of people are staying away from that. I
Mm.
mean, the supercomputing systems, like Cray has been doing that for over 25 years, kind of went away from it. I think maybe the government labs, the true supercomputers will use it, but I don't think a lot of the normal data center companies are going to be
Mm.
going that way. Maybe crypto mining at the most. I think the direct to chip is a little bit easier, less fundamentally different architecture, and you'll see that be the primary way to cool things in the future.
So, Bob, can you spend a little bit of time on, what structured cabling solutions can do to help maintain airflow and manage dense fiber requirements?
Sure. There's a couple different ways to do your cabling. You can do the point to point, which is what a lot of the supercomputers and previously were doing, and which, some of these high-end systems are still doing. And that just means exactly what it says. Cabling directly from the server to the switch, nothing in between. That's going to be the least expensive, and it's really good if you have a small AI system. But as you start to scale out and you have multiple rows of multiple server racks, it becomes more difficult because now you have those cables going in many different directions, and port mapping becomes very, very important. And when you have these cables going around and something gets damaged or something's not put in the right place, debugging it and point-to-point cabling gets really tough. So what a lot of people have been doing for many, many, many years is structured cabling. And what you end up doing there is you have demarcation points. So instead of going directly server to switch or switch to switch, you go server to a patch panel, which is just an adapter or a coupler. And then you have another cable to another patch panel and then down to the actual other side of the electronics. So what that allows you to do is before the server racks and switch racks have ever been installed, you can hang your pathways, which hang above all these racks. You can put in your long cables into those pathways. You can connect them into patch panels, test it, make sure everything is good, so that when you bring in, and this is mostly an AI, racking and rolling these cabinets in, you slide them under those patch panels up above, and then all you have to do is a quick patch cord or jumper from the server up to that patch panel. And then if something doesn't go right or there's some mistake, you're just dealing with maybe a 3 meter at most patch cord, very easy to fix. And you don't have to go digging into the pathways up above. So it simplifies troubleshooting. It actually dramatically speeds up the install because all the cabling is put in place that you don't want to touch, and then you're just dealing with those short patch cords. And then you can also put trunks with structured cabling. Allows you to, like I was saying earlier, consolidate a lot of those individual fibers into single trunks as high as like 864 fibers, 3,456 fibers, and that takes up a lot less room in the pathways. So the structured cabling gives you a lot of advantages. Debugging removes the slack, and if you do have slack and you've overestimated how long your cables are, it gives you room to coil that stack up into. So that's really a big help when you're trying to future proof and think about adding on to your system and just making it go up and be running as quickly as possible right as soon as you get those racks put in place.
Okay, I want to talk about a very super tactical thing, but in my intro, I talked about the all the things that go into running the infrastructure of our world. In this specific case, AI computing, and it goes down to every little detail, and every little detail feeds into the bigger picture. You know, those fancy, pretty light servers and all that stuff that everyone knows and doesn't know about all the stuff that we're talking about because they don't see it. So I'm curious. Let's get down even to the connector. Is there something connectors can do to make a difference in this space and installation challenges we have?
Yeah, there's several different products that have been coming out over the last couple of years. The VSFF, which just stands for very small form factor, is doing exactly what you were just asking for. It's shrinking. You have one that shrinks down to duplex LC to 1/3 the size. And now you've got one for AI, which shrinks down the MPOs down into 1/3 the size. The most popular ones are the Senko SNMT and the US Connect MMC. Both of those are primarily right now 16 fibers. So they're about 1/3 the size of a MPO that can host 12 fibers. So now you're getting more fibers and less space. Those transceivers have not caught up with that yet, so you still need an MPO when you go into the server, into the switch. But when you go into your patch panel, imagine now you can triple, quadruple, and put upwards of 3,456 fibers in a patch panel. Not sure everybody really wants to do that because of the space, but you're able to really get a ton of density in those patch panels. And then I think even more important is when you go to pull those cables through the pathways, and with AI, there's a lot of congestion because we talked about 8 to 10 times more fiber pulling through those pathways. Things get bound up and tied up. Most of the big guys want pre-terminated cable assemblies because they don't want their contractors on site terminating, splicing, because
Mm,
there's just a shortage of those people with the very overheated market we have today. So shipping a pre-terminated cable assembly means pulling a cable with a bunch of connectors on it through your pathways, much like you're trying to pull connectors through, to do electrical work inside your walls. There's
mm,
all sorts of things that'll get caught in there, and so you're fishing it. Very similar. You put it, wrap it up.
mm.
It bundles up and makes it a smoother, rounder section that pulls through easier. But if you can take every one of those connectors and shrink them by 2/3, it makes it way easier to pull through. So I think that, if anything, is where these VSFF connectors really help out in these highly congested AI networks.
Okay, so we've talked about a lot of different solutions, and so I'm curious, how are these solutions combining together to future-proof data centers facing rapid AI adoption?
Yeah, so the if you know you're going to go AI, and if you're going to build a new data center, you should be betting you're going AI because that's what almost everybody wants. You first of all, you got to start with being able to have 415 in the building. You're going to want to lay out some sort of plumbing. If you're an MTDC co-location, that becomes a little bit more complicated because you have multiple tenants. Some may want AI, some may not. But if you're building a data center for yourself, you should start putting that plumbing in now because that'll future proof it. Whether it's going to be a liquid like water or one of the coolants, it shouldn't matter too much, but you can put all that in. You're going to want to plan to have your racks in a location that's going to be easy to scale out as well as
Mm.
scale up. Scale up means you're putting more and more into each rack so that those GPUs even closer communication. I would highly suggest using structured cabling as much as possible because as you add on, think about the cost of these GPU servers. You may not be able to afford everything up front, but as you add on to it, if you put structured cabling in there, it makes it way easier to scale out, especially from switch to switch as you start to add maybe more layers of switching as your AI factory gets bigger and bigger. So these are many things you got to be think about for future proofing. And if you do have a raised floor, you should really make sure that your raised floor is going to be able to handle the weight. These AI servers are much heavier. The cabinets are being designed to be stronger. So today's typical raised floor may not be able to handle that sort of weight load on top of it.
Okay. Hey, I appreciate your time today, and this is exactly why I wanted to have you on because you've introduced me to a lot of concepts I hadn't really thought about around AI and the computing and the cooling and all the things that go into feeding the data into those sexy machines that are doing all the blinking and lighting and computing. So thanks for that, Bob. But I do want to close out our conversation by refocusing on the why of what we do. So what motivates you day in and day out? What keeps you excited and passionate about what you do?
I would say it's always been about new products, new development, um, coming up with things that solve the customer's problems. And I mean, AI has been fantastic for me. It's been great because there are a lot more problems than there ever were before, and it's really cool technology and the what the software systems can do to make people more efficient. And like we're talking about solving genome problems and health risk
Mm.
issues that AI can hopefully really help with just the humanity. It's very easy to be motivated. It's been fantastic. I'm really loving being involved in the AI, and so couldn't be happier right now.
Great. Well, Bob, thank you so much for bringing that energy and passion, and thanks for being here. And it's been great having you on the show.
Thanks. It's been enjoyable to talk to you as well.
Thanks. Well, that was my conversation with Bob Wagner, Senior Business Development Manager for Data Centers from Panduit. You can connect with Bob and Panduit to learn what they're working on by heading to the links in the show notes. I would love to hear what you're doing to support and build out the AI infrastructure. You can email me at podcast@graybar.com or comment on Spotify or YouTube. If you enjoyed this episode, you can help us grow the show by subscribing and leaving a 5-star rating in your favorite podcast player. Thanks for listening to this episode of Keeping the Lights On. We'll see you next time. So, do you have a favorite hobby, media, book? It could be anything, an activity that inspires you, Bob, that gives you energy.
Yeah, and I'll be honest, I wish I did it more often. Is hopefully when I retire, I'll have more time. But my wife got us involved with it's called the Hesed House. It's a local house where people go to when they don't have anywhere to live. And what's amazing is I think a lot of people have bad thoughts about why people are in those situations. Most of the people just have no network and background that someone can help them out, and they just are so grateful, and they have like almost nothing. So helping those people out, just it makes you feel good, but you also realize just how bloody lucky we all are if
Mm.
we're not homeless. So I would love to do more of that, but yeah, that's what really inspires me to be a better person.